really understanding it. I'm aiming this talk at people who are very new to quantum physics and quantum computing and want to see where they entangle, excuse the pun. So again, I'm very strong on the questions, which Subodha will look at anyway, but just think, is this going to help most of the people in the group? If you've got a very technical question, you know, DM me later and I'll speak to everybody on their own technical questions. But this presentation is for someone new, and I don't want to lose them. And the reason why I don't want to lose them is so fantastic. Here's the 3 experiments I'm going to talk about today. And these experiments are real, scientifically proven. They happen every time. Now, the interpretation of what's happening is a different thing. I love quantum physics, and I keep telling people, you don't have to be clever to be in quantum physics, because all you need to say is what is happening. You don't have to explain why it's happening, because nobody knows. So these experiments, they occur time and time again. And quantum physics is far more reliable than any other part of physics, classical physics or Newtonian physics. I mean, what happened with scientists when they first went subatomic, so when they first had the technical equipment to look inside an atom, they were absolutely amazed. We're talking 100 years ago. They could not believe it, because the Newtonian forces of gravity, electromagnetism, strong nuclear, which are gluons and keep us together, and weak nuclear, which is radiation, those forces don't exist in that level. But they're replaced by these very, very weird forces, which we still don't know how they work, called superpositioning, quantum entanglement, and quantum tunneling. And these forces are real. And we don't understand how they happen, and they're mind-boggling forces. If you've never heard of these before, like the double slit, you'll think, what is this guy talking about? But I guarantee to you it's all true. And it's very reliable. In fact, the fundamental law of the universe is quantum mechanics. I've had people say to me, oh yeah, well, but what about in the real world? Hold on 1 second. Everything in this universe is a quantum object, including you and I, including the mouse, including the microphone. Everything goes down to a quantum level. The Newtonian world and the classical world we see and interact with is, in fact, an emergent property. The reality of, and some of the stuff I'm going to tell you today, you just won't believe. So I'm talking about 3 experiments: the double slit, the delayed choice quantum eraser, and Wigner's friend, which is actually what's called a Gedanken, a thought experiment. Einstein did these all the time, but Wigner is the pronunciation, I believe. I've heard different things, but Wigner's friend, there was an experiment done just 1 year ago, and you may or not be aware of it, out of the University of Edinburgh, which is by Massimiliano Proietti, Italian guy, I'm assuming, which proved objective reality doesn't exist. So we can have more than one reality in our universe. I know this sounds crazy. Can't wait to talk more about it. And that opens the door to one of the interpretations of quantum physics, which is Hugh Everett's The Many Worlds interpretation. And we will be getting into that. But Massimiliano Proietti's experiment in Edinburgh University, based on Wigner's friend, proves it. Fantastic stuff. And then finally, as if that's all not enough, I'll be talking about consciousness and the Radin experiments. Professor Radin is a head scientist at the Institute of Noetic Science, and he claims, and I'm not saying he's right or wrong, but his interpretation is that consciousness is collapsing the wave function. And don't worry if you don't know what that means, because I will soon be telling you. So with no further ado, let's get on to the double slit. And I'll tell you now, the double slit in the science community is known as the beautiful experiment. And there's a good reason for that. It's incredible. It's something that we can explain easily what's happening, but we cannot explain how it's happening. And the greatest man, Einstein actually, first of all, said it wasn't happening. He just couldn't believe it. And modern theoretical scientists like Leonard Susskind, one of the leading lights, he thinks that it's like a wormhole, and the Einstein-Rosen bridge, the bottom of wormholes colliding. It's crazy stuff. But I am going to talk about this I'm just going to tell you what happens, and then we can discuss the interpretation. Now, the double slit, believe it or not, goes back to 1801 with a professor called Professor Thomas Young. Because back then, 200 years ago, one of the main questions facing physicists was, is light a wave? Is light a wave or a particle? So if you look at the graphic here, you will notice there's a front slide and a back slide, the detector slide. And what he did was shone a bit of sunlight, so he got the curtains and he had a little bit of light coming through into this front slide with two very, very small slits in it. A lot smaller than that. That's just for narrative purposes so that we can talk about it. But these are minute slits. Because his thinking was, if we look at the detector board at the back, that's here, we will see a pattern. Now, if light is a wave, we will see an interference pattern. And I might just annotate it to make sure you know where I am. But I'm talking about here at the back. And if you get a number of lines just coming from these two slits, it shows that light is acting like a wave. Just imagine physically in the Newtonian world, if we were pushing water through those two slits, the waves would interfere with themselves. And when they touched the back detector slide, they would touch them in different areas. Alternatively, if we had a machine gun and we were firing bullets into these two slits, we would expect to see just two vertical lines at the detector board. Now, it's very important you understand the detector board. If there's an interference pattern, like this one, multiple lines, it means there's a wave happening. And if there's just two vertical lines, it means it's a particle happening. And that's very important to understand this. Now, in 1801, the wonderful Thomas Young said, oh, great, look, it's an interference pattern. Everybody, I've solved it. Light is a wave, just like sound. And he did a lap or two of the laboratory and he was happy. And for 100 years, it was accepted science that light was a wave. Now, in 1905 and 1912, I can't remember the actual year, but I put 1912 and it doesn't really matter. This man, who I think we all know, Albert Einstein, he did an experiment called the photoelectric effect. And incidentally, he got his Nobel Prize for the photoelectric effect. He didn't get it for the wonderful work he did on Brownian motion, the specific theory of relativity, and there was one other, escapes me now. And Einstein, just to tell you how wonderful he is, he did 4 accepted pivotal white papers in the 1 year, whereas most people will just do 1 in a lifetime. It was amazing. But the photoelectric effect proved, and I won't go into it because of time, proved that light was a particle. Now, Einstein said, hold on a minute, I'm not saying Thomas Young was wrong, because I've checked it out and it's right. We've been checking it out for 100 years. But it seems that light, which is a photon, so the empirical unit of light is actually one thing called a photon. Sometimes that photon is a wave, and sometimes it's a particle. And Einstein and the whole scientific community thought, well, we don't understand what's happening. Then what happened in about the 1920s, 30s, we developed the technology to fire 1 photon at a time. Because what we wanted to do, we wanted to see what was happening with this, what was making it a wave, and what was making it a particle, and what was this strange wave duality. And then what happened was an amazing thing. When we fired electrons through the double slit into the, and I'll put the annotations back on. Oops. So when we fired the electrons and they went through the slits, and they actually gave this many interference pattern at the back, we thought, okay, let's get a very sensitive camera, and what we'll do is, and by the way, it's not a camera like that, it was a scientific camera, I just used that as a graphic. Now, we said, let's put it on the slit, let's see which slit it goes through, and then we'll find out what's happening. But amazingly, what happened was, it changed into a clump. So again, if I can just spotlight it, it became here at the back, and the interference left, and the clump came. So by putting a camera there, it changed the fundamental properties of that unit of light. It changed it from a wave to a particle. And this was amazing. And the important thing to note is that it was black and white. If we didn't look, there was a clump. If we put a camera there, I'm sorry, if we didn't look, it was an interference. If we put a camera there, it became a clump. Now, this was very strange. What happened, I want to stress that it's not the fact that we didn't have powerful enough equipment. We did, and we have now. But nature itself is preventing us from investigating what's happening with the interference. It's not allowing us. It's sort of saying, well, if you put a camera there, if you know which slit this photon's going through, then I'm going to stop being a wave and I'm going to be a particle. It's amazing. So before that, and what was turning it into a particle seemed to be the fact that we were measuring it. And this is called the observer effect. Now let's get one thing straight away. Observer's the wrong word, measuring's the wrong word. We don't have the right word because we don't live in the quantum realm. We're not used to what the right word is, but somehow, we'll carry on calling it measurement. Somehow, when we try to measure the wave to find out what's happening, it becomes a particle. So this particle, before it's measured, is said to be in superposition. It is actually in many states at the same time. And amazingly, we can actually, even though we don't understand what's happening, we can actually reference and map to these imaginary states using imaginary and complex numbers. We've written an equation called Schrodinger's equation that will actually take the wave over time, and we've actually got, we can tell the probability of each little stage of the wave function. It's called Born's rule, and we can work out the probability of collapse there. It's the, for you guys on the Kiskett course, that Born's rule is that the probability of psi is the complex amplitude coefficient, the absolute value of the complex amplitude coefficient squared. So, I mean, it's just amazing. And the observer effect, so if we're looking, if we have a camera there, it collapses the wave function. And for those of you new to the sector, remember that phrase, collapsing the wave function, because that's what it's all about. I say that's what it's all about, but I think this is even more important. And the lovely guy here is, I'll do annotations again, just so that you can see where my mouse is going. But this is John von Neumann, one of the greatest theoretical physicists of all time, way up there, possibly beyond Einstein. You know, it's like comparing Lennon and McCartney. But von Neumann was interested in the measurement problem. Where is the measurement? So if we put a camera and if we look at the wave and change it into a particle, where is that happening? Is it happening at the measuring equipment here? Or is it happening on the plates where it's being recorded at the back screen? Is it in the eyes of the observer? Is it in the mind of the observer? And then after this, is it in the consciousness of the observer? Now, nobody knows. So again, we get back to these interpretations, but the experiments I'm going to talk about in a minute, the delayed choice and Wigner's friend, will address this issue. But I want you to know what von Neumann said. And I might add, the big heavyweights of quantum physics, Niels Bohr, Paul Dirac, Schrodinger, Max Born, all these people agreed with what I'm about to tell you von Neumann said. He said, it's only when the interaction, the observing, the measurement, let's call it, reaches what he called an extra physical entity, which is consciousness. He was saying, like I said to you before, we're all quantum objects. We're all made of quantum objects. So when you have two quantum objects, the wave function and the camera, there's no measurement. Then an observer and the wave function, there's, again, both quantum objects, there's no collapse. Again, with the eyes, and we can show it with the eyes because if you had a 5-year-old looking down the camera lens, not aware of what's happening, it wouldn't collapse the wave function. It would remain as a wave. So it's not in the eyes, because that's a quantum object. It's not in the brain, because that's a quantum object. It's actually not in the mind, because that's still a quantum object. But consciousness is not a quantum object. And von Neumann was saying, when the wave function meets consciousness, a non-quantum object, it collapses. And that's amazing. I want now just to relate it quickly to quantum computing, and then perhaps, oh, I shouldn't have done that. It's going to get in my way later, so. Suhoda, if you can then ask for some questions. But I wanted to show you how relevant this is, because let's look at, and this is for the Qiskit guys. We hear in computing the qubit collapses to 0 or 1 with equal probability. And so we do all our mathematics that way without understanding what does that mean? What does that mean? And that is actually collapsing the wave function. So if we measure it, as we've discussed, it collapses the wave function, and because we're in like the Bloch sphere, it will go to the highest eigenvalue to 0 or 1 with equal probability. But you see how what you've been, if you're just approaching it from a computer aspect without any knowledge of quantum mechanics, you won't quite understand that. So I hope that helps. Born's rule again, the probability of the wave function collapsing at any particular point is equal to the absolute value of the complex amplitude squared. Well, so that's just saying it will collapse in conjunction with Schrodinger's equation. So again, the underlying physics is important. Remember the Bloch sphere for the Qiskit people and the surface locations of the Bloch sphere? That's when we're in a pre-collapse state. So the Bloch sphere is replicating the wave function. And the no cloning theorem, by the way, guys and girls, a quantum computer cannot copy and paste. I know it sounds amazing, because you cannot. It's the no cloning theorem, and the reason why you cannot, the underlying quantum physics, is because Werner Heisenberg's uncertainty principle said that we cannot know the momentum and location of a subatomic particle at the same time. It's not that we don't have the equipment to do it, it's that nature does not allow us to know both. And just remember, in 100 years, 50 years, whenever, soon, the whole world will be operational through quantum computers. There's little doubt of that. Quantum computers will control society. When we have a quantum computer with 300 qubits, pure logical qubits, we'll be able to map to every atom in the observable universe. Now think about that. In my study here, there's billions, trillions and trillions and trillions and quadrillions of atoms. Without going out into Perth, without going out to Australia, the whole globe, the whole solar system, the whole galaxy, the whole universe. It is incredible. And that's only a 300 strong quantum computer. So we're going to be controlled by a computer, and we don't understand what's happening. Okay, Shaholda, are you there? Subolda, are you there?
Yes, sir, I'm here.
Lovely, I can hear you well. Are there any questions you think worth looking at the moment?
There was one by Praveen. It said, how do we know it's an interference if we won't look?
How do we know it's an interference? We look, because of the back slide, it shows the interference pattern. So we know some interference is taken. I hope that explains it. That's how we know it's an interference, because as the questionnaire quite rightly thought, if we actually look at it, then it becomes a club. And then it becomes a particle. There's no interference there. So we know it's there by the secondary fact that there's an interference pattern.
Okay, I hope that answers it. Another question is, you can measure something in a right way when you are conscious about it, you know about it. So that means people until now have not understood the laws well enough, suggesting that is there a question here? So what's your comment on the, I don't think that's a question. Isn't entanglement an important issue, important aspect, because the state is no separable, so you can't clone it.
Okay, I'm not 1,000% with the question, but obviously entanglement is an exceptionally important point, which I will mention when we get onto this delayed choice. What was the beginning? Because I was going to make a comment on that. It's better just Subodha speak, because if too many people try and speak, I can't hear. Subodha, just repeat the beginning of that question.
Those were the two separate questions. First question was, you can measure something in the right way when you are conscious about it. That is,
okay, stop there, Subodha. Yeah, you can measure something when you're conscious about it. I think the problem we have, not the problem, but the issue with a lot of questions I get all the time from the audience, the issue is almost always, hold on guys, we're talking at a quantum level, this happens. At a classical level, this does not happen. So there's no such thing as superposition in the classical world. So consciousness, which we don't understand, we know we don't understand it. And in fact, Radin experiments, this is the whole point. The Radin experiments is opening the door to the consciousness. There's a thing called micropsychokinesis, which is the projection of thought affecting an external object. Now, look, you guys in India, I know you're all mystical, and I know you probably said we've been saying this for thousands of years, and you may well be right. But if Dean Radin, if his experiments are accepted, then it's opening the door to micropsychokinesis, which then opens the door to telepathy, clairvoyancy, forethought. It's just that we're not very good at it. But Subodha, can I continue, do you think?
Yes, sir, please do.
Thank you very much. I love the double slit, but the delayed choice quantum eraser is the best. It is quite complex, so I'm not going to go into it, but I'm going to take you through it with hopefully enough explanation that you can just try and understand what's happening. It's amazing, and I'm more than happy to come back and explain it in more depth. I mean, you could talk about this for hours on end alone, but I'm trying to fit it in to the presentation. But look, the Late quantum eraser is basically the double slit with, as soon as the photon goes through the slit, it's entangled through a thing called the BBO crystal, barium, borate, something, doesn't matter, but it entangles it. One of the questionnaires before, great question, mentioned entanglement. So for those of you who have no idea what quantum entanglement is, it is the most amazing thing. Again, one of the forces of quantum mechanics. So it only works in the... Guys, you're going to have to... Don't unmute yourselves yet. Quantum entanglement is where you get a subatomic particle here, you get one here, You untangle it, you take it away to the moon, and then as soon as you change this one, that one changes. Now, I always say this to children. I put a little speck of dust on their finger, and I hit it, and I say, a speck of dust on the moon has just moved, if there was an entangled speck. Well, you tell me, I'm asking you, what's happening here? That's something a million times smaller than a speck of dust knows when something in the moon, and actually it's something at the other end of the universe, we think. The furthest it's ever been done was last October by the Chinese with the Messias spacecraft orbiter around Earth. So they actually did, it's quantum teleportation. I'm not going to discuss that today, and we did a bit of it in Pisces. But an entanglement was proven between a subatomic particle in a laboratory in China and on the spacecraft orbiting the Earth. And immediately, instantaneously, they come up, they both change. How does the one on the moon know that this speck of dust has just changed? We don't know. Einstein famously called it spooky action at a distance, and he claimed it never worked. There was a hidden variable. We have now, through great work by the Irishman, and by the way, guys, I'm not Australian, I'm English, and my parents are Irish, so I love Ireland, and the very, very clever Irish physicist John Bell proved it mathematically that quantum entanglement was real and was happening. It wasn't just, Einstein was suggesting, it's like having a left shoe and a right shoe here. And if you take the right shoe and put it on the moon, as soon as you know you've got a left shoe, then you know that the one on the moon's a right shoe. But he was proven wrong, and the delayed choice proves him wrong too. That was a long-winded way, but it was important so that you know about two phenomena now: superpositioning, where this wave of probability changes into collapses into a particle at superposition, and then entanglement, where this non-local is the important thing. And Einstein didn't like it because it happens instantaneous. So something's happening faster than the speed of light, which disproves general relativity, Einstein's other wonderful work, which I've got a video on Queckler. But so it's amazing. But the double slit combines both of them. Now, what does it prove? The delayed choice quantum eraser shows that just by knowing the which way path of the photon, it collapses the wave function. Now, that's important because people were saying, well, when you measure it, the measuring device sends a photon, and then if it hits something, that's how you make a measurement, by interacting with whatever's happening. So maybe it didn't explain why it would go from an interference to a clump, but it was strange. So the DCQE proves that, oh no, wait a minute, don't bother doing a measurement. No measuring equipment, throw the cameras out. I'll prove to you that if you know where it's come from, which slit it went through, it's called the which way. When you know the which way, it will collapse the wave function. And obviously you have to be conscious. You have to consciously understand the which way. And then, this is amazing, listen to me, and you're not going to believe this. The delayed choice quantum eraser shows us that don't unmute yourself, guys. Stay on mute. The DCQ, and by the way, when I say guys, I mean guys and girls as well. The delayed choice quantum eraser proves that events that have already happened can be altered. time does not exist in the quantum realm. And that's important. I always say quantum mechanics is a mystical combination of almost all of these sciences, including metaphysics, philosophy, theology, epistemology, cosmology, and quantum science. It blends it all in together, and it's very interesting and exciting. And the amazing thing is that we can build computers out of it. But is that unbelievable that events that have already happened? And I'm going to prove it to you now. Events that have already happened can be altered. Now, there's just a little bit of equipment you need to know. Look at the time. You've got the, oh, we're going okay for time. It's only 5:12. I'm only going to mention 4 pieces of equipment, so it's not difficult. You've got the BBO crystal, and what this does is entangle one photon into a pair of entangled photons. It's a well-known scientific fact. If you get one photon coming in and it hits the BBO, it becomes 2 entangled photons. A prism, that's just a way of directing the photon. And then a beam splitter, this is worth noting. A beam splitter is an amazing little piece of, it's like half a mirror. What it does is it has a 50% chance when the photon comes that it will bounce off, it will be reflected, and a 50% chance that it will go through. And that happens extremely reliably, regularly, and we can't tell why it does it. Just sometimes, half the time it goes through and half the time it bounces back. And then we have our detector boards. I love all these questions in the chat room. I'm sorry I can't look at them. Right, now, here we go. This is the delayed choice. So I'm going to start off by showing you the equipment. So, look, it looks extremely complex, but it isn't that much. We spoke before about the BBO crystal. Well, here's the BBO crystal. This thing here. So when the photon comes through the top slit, it hits the BBO, and when it comes through the bottom slit, it hits the BBO. The BBO then creates 2 photons, one that goes that way and one that goes that way. And then that's from the top. And then from the bottom, one that goes that way and one that goes that way. So it's not that difficult to understand. It just creates 2 photons, and then through the prism, the GT prism, it sends it in 2 different directions. Easy. We spoke about the prism. Well, there's a prism there, the GT prism, but here's another prism, and all that does is, like a normal prism, it actually refracts the light and, moves it away from the other light, so there's no, the paths are completely unique. Then we can come to the beam splitters, these wonderful things here. The green rectangles, 1, 2, 3. And you can see that a light coming, and I'll go to, I'll use my spotlight for this. So a photon that happens to come here, 50% of the time it'll bounce off, 50% of the time it will bounce through. It won't bounce, sorry, it'll just go through. And here's a mirror at the back, and then it comes through another beam splitter. 50% of the time it'll go to detector 2, 50% of the time it'll go to detector 1. It's really not that difficult, guys, and I'll now show you the detectors. So here's detector 1, here's detector 0, sorry. Then we've got detector 1, detector 2, detector 3, and detector 4. So when the photon finally gets there, I mean, that gets there pretty quickly and straight at detector 0, but to get to detector 1, it may travel from the top, it goes through the beam splitter, hits a mirror, goes through the beam splitter and hits it there. Or it could go a different way. It could go through the bottom and it could go through the beam splitter. Oh, I just thought I hadn't. Why haven't I got the spotlight so you can see me better? It could go through the beam splitter, go through that beam splitter, or bounce off. There's a many. The point is, on some detectors, we will know the path it's taken, and on others it won't. And let me just prove that to you now. When the light comes, let's look at detector 0. We don't know if it's which path it's coming through. So if it comes through the top slit, then it will go through the lens and it will hit the detector. But it could also go through the bottom slit, and one of the entangled photons from the bottom slit will come through here and hit the detector. So guys, I'm asking you, what pattern would you expect at D0? Would you expect to see a clump or an interference pattern at D0? And I'm looking in the chat now. You can say, thank you, Yash. No, I know I'm probably not saying the name, but it's an interference because we don't know where it came from. Thanks, Sagnik. Oh, I love these names. Let me get the Anna. Yeah, I know you're all getting it right now that the others have got it. Let me get the spotlight back. Now, so D0 and a few of the others, D1, we don't know where it's coming. But look, let's look at D3. Now, D3 can only come from the bottom slit. Half the time it will bounce here, but if the photon gets to D3, we know without a doubt which slit it went through. We know the which way. So I'm now asking you, what pattern would you expect to see at D3? Yes, thank you, Anurez. Thank you, Bhavan, Samarpan, Akash. On and on. It's a clump pattern. And that is what happens. And it happens every time. Now, that's unbelievable, because the only difference between those two photons is that in one case, we know where it's gone, which slit it went through, and in the other, we didn't. And by bouncing it off the beam splitters and going through, it's, thanks guys. It's amazing that by doing that, by losing the which way, we're erasing our knowledge of it, changes the fundamental nature of it. I hope you find that amazing. And now I'm going to tell you something even more amazing. We will look at D0 and compare it to D1 and D3. Now, when the entangled pair, so the first entanglement gets to D0. Now, the important thing is it gets to D0 first before it gets to any other detector. And we've already agreed that there should be an interference pattern here because we don't know which way it went. But its entangled partner is going on a longer journey. It's going through the prism. It may or may not, let's assume D1. Actually, let's not assume D1. Let's assume D4. It'll take it a bit longer and it'll get to the beam splitter. Now, it could go through or it could reflect. In this case, it's reflected to D4. Now, if it hits D4, it's hitting D4 after the other entangled photon has hit D0. And remember, the entangled photons have to be the same. But the bottom one hits D4, and we know which way it's come, so it's a clump. Amazingly, a clump will show at D0. And now, don't worry if you're not totally with that, but don't forget, one's taking longer. It's going through beam splitters, 50-50 which way it's going to go. But the one that's already reached there will show the pattern that eventually happens to its entangled partner, even though we don't know what that pattern will be. But 100% of the time, if it's a clump, then D0 will show a clump. Now, again, it's how we interpret this. This happens, and it happens all the time. Why it's happening, we don't know, but we certainly think there's a case to say that somehow this thing, a million times smaller than a speck of dust, knows what's going to eventually happen to its entangled partner through the beam splitters. And I think, guys, you'll agree that is amazing. Now, I know you have loads of questions. I'm going to very quickly say that John Wheeler said that the same thing applies if it's a photon coming from a distant quasar. It may have traveled billions and billions of years as a wave, but how we measure it today, i.e. whether we look at it at a telescope and we know where it's come, which quasar it's come from, then it will be a particle. If we look through, let's say, an interferometer, I can't go into what that is at the moment, but if it's looked at an interferometer, then we don't know which way it's taken. So there's an interference pattern. So what we're saying, what Don Wheeler's, and this is a Gedanken, a thought experiment. The rest happens in a laboratory. This is just a thought. Well, with a lot of credence, I might add, that the photon may have ostensibly traveled for 10 billion years as a wave function, but if we look at it through a telescope and know where it's come from, we know the which way, then it becomes a clump, a particle, and has always been a particle. The whole of 10 billion years has been rewritten. That's amazing. So, Subodha, I might have time for one question, but I'm just conscious of time. We're coming up to the hour mark, and I want to be about another 20 minutes. And you've got to hear Wigner's friend in consciousness. So, in fact, if you don't mind, I might just carry on. Or is there a question you'd like answered?
No, sir, I cannot find any good question. I think we can carry on and we'll answer the question after the session.
Thank you very much. And yes, the point is, as Subodha says, at the end of the session, I'll answer any question, and you can email me any question on the Quaker Facebook page. So, this is brilliant. Wigner's friend. I'll go through this pretty quickly. If you're new to quantum physics, your head must be buzzing now. And I'm going to explain this as easily as I can, but the Kiska people will love this. Wigner's friend in the 60s said, now hold on a minute. I may be in a room and I may collapse the wave function of as we've discussed. So I measure the wave function and I collapse it. Yet, what's happening? He's saying Wigner's friend. I'm going to have to. Oh, I didn't mean to do that. I'll do an annotation so you can see where I'm going. So this is Wigner's friend, and this is Wigner. Now, unbeknownst to Wigner, it's like if I said to Saboda, hey, look, I'm going to go down the shops. You do this collapse for me. You collapse this wave function while I'm away. Yet, so for Saboda, for him, he's collapsed the wave function. But for me, I've not measured the wave function, so it hasn't collapsed for me. And this is an extension. This is Wigner's friend here. And it says here, but hold on, there is a professor who's observing the observer and the particle. The point is, remember I spoke before about quantum objects? Well, the wave function and Wigner are quantum objects. So if an observer observes an observer and the wave function, for the Wigner's friend, the observer, this guy, for him, the Wigner and the particle or the wave function is entangled. And we can prove that mathematically, and I'll get onto that in a second. But do you understand that, guys? So because they're all quantum objects and it hasn't hit consciousness, it's amazing. So he's the guy, Wigner's friend is saying, hold on, I'm collapsing the wave function and you're just experiencing that collapse. Now, this is, number one, supporting the many worlds interpretation of Hugh Everett. And I wish I had time to go into that, but I don't. And it's saying that there's, and this is the amazing thing, it's saying that there is no objective reality. You can have different universe, different realities in the one universe. You can have different worlds, and you create your own world as an observer. It's like Saboda and I going into a room, and for me, there's a television there. For him, there isn't. Now, we've always thought, look, there's one reality, and we can both interpret it in different ways. But this experiment I'm about to introduce you to now, and by the way, I've got all the links and everything on the slides, so you can check this out. Massimiliano Proietti, Italian, excuse my poor Italian pronunciation, is the guy on the left. I was about to say the guy with the glasses. That wouldn't have helped. It's the guy with the black glasses, and the other guy's Alessandro someone, and he has blue glasses on, and they're wonderful people. And what they did was they used 6 pairs of entangled photons to establish the existence of multiple realities in the one universe. And this is basically it here. And it's the same thing as the observer observing. So the observer collapses the wave function and then stores it on an atom. Let's not get into that. So the guy who's remote, Wigner's friend, collapses the wave function because he's observing it, but the person locally has not collapsed the wave function. So is that wave function a wave function or a collapsed particle? And it's both, according to Massimiliano. Again, I'm not saying this is the reality at this stage. The double slit, the late church quantum eraser, they're facts, they happen. you can try and work out what's going on. This is a Gedanken, Wigner's friend, but this experiment that only happened last year happens. So now how are you going to interpret that? Massimiliano and Alessandra say there can be, objective reality doesn't exist. There can be many realities. And even more than that, we create our own reality. And I know in the mystical world, you guys will have something to say about that. Again, I want to stress, this happens in the quantum world, no question. We're beginning to entangle billions and billions of atoms together now. And they're classical. You've got fermions and hadrons, and the Large Hadron Collider and CERN, but we can't have time for that. I'm going to very quickly, and this is the most important thing. It's 5:32. I'm going to take 10 minutes, and they will have questions. The Radin experiments. I hate to rush this. Professor Radin there is a hero. Honestly, he's a hero because he said, remember before I said an animal can't collapse the wave function, a 5-year-old boy can't collapse the wave function, but somebody consciously knowing what's happening can. And Radin said, look, everybody's saying it's consciousness. There's obviously consciousness. I'm going to prove it. And this is what he did I know you. Great comment, everybody. I can't get into conversations at the moment. I'm sure you understand. I've been following this guy since 2012, and what he did, and I'm going to do this very quickly, he set out to prove that consciousness collapsed the wave function. What he did was then get a team, probably from India, Tibet was involved, I know that, of transcendental meditators, people who were in touch with their consciousness. So he had the double slit set up, he had them in the room, and they could try and imagine the photon going through one of the slits. So they were told, think, 10 seconds, stop thinking, relax. And during those 10 seconds, they would consciously try to collapse the wave function. And you are going to love this, but the transcendental meditators, according to Radin, were significantly better than ordinary people. He then tried it in different rooms. They were still significantly better. And then he went to different countries. So over the internet, you had somebody 40,000 kilometers away over the internet trying to collapse the wave function. Now, here's an amazing fact. Fact according to Radin, statistic, if you like, whatever you want to say, but he has 80 gigabytes proving this stuff. And he's proven it to 4 sigma, which is higher than the proof that was given for the Higgs boson. He always jokes that they got a Nobel Prize and he's still waiting for his. And the results have been replicated by different teams doing his experiments. Not conclusive, but it doesn't matter. Let me just say, over the internet, what they did was, and you clever guys in India will know this, Linux, he set up a open source simulation of the results. So they would be on the internet, a red light would come on, they'd think, and then the green light would come on, and they'd think, and then the red light would come on and they'd relax. Now, that information is obviously sent as data over the internet. And amazingly, this little thing, a billion times smaller than a speck of dust, seemingly could tell whether there was actually a human being or a Linux simulation going on. That's unbelievable and leans towards it being a consciousness that's doing this. Now, not everybody, it's not science. Dean Radin says, what do I have to do to get you guys to believe me? And look how recent this was. Just a year ago, Wallace von Stilfried said, no, Dean, we don't believe you. We think your experiments are biased. We think there's a false positive effect. There was a very famous science experiment where the people could show and prove that neutrinos were going faster than light. It's called the opera, if you want to look it up. The opera experiment, OPERA. And what happened was 3 years later, they proved that no, there's a false positive effect going on. That is, when you know and want a result to happen, you will unconsciously be biased. And that's the best I can do to explain that. Here's the research references, the YouTube videos I recommend, the Wallace von Stilfried rebuttal, so it's still rebutted. I might add, Professor Radin has rebutted their rebuttal. So it's a bit of stalemate at the moment, but things will happen. And this is a lovely YouTube explaining Wigner's friend. And here's the papers, the white papers from Massimiliano Proietti. And that, ladies and gentlemen, is the end of the course. Why am I not coming up here? Are you there, Sabuda?
Yes, I'm there.
You're a wonderful man. You're always there. Now, that's the end of the presentation. I'm not sure why. Oh, you can see my. Yeah, I am here. I was wondering why I wasn't here. Okay, I'm ready for questions if you want to arrange that, Sabuda. Hello, Minati Rath. Oh, that's a lovely thing to say. Thank you. Thank you, thank you, thank you, thank you. Thank you, Sagni. I'm saying that right. Thank you. But if any of you have a question, I can answer it now. You've been very patient. After all, you've been so busy, but it's been an hour and 10 minutes, so that's not too bad. Sorry, there was a question. Oh, well, Sabuda, do you want to ask? There was a nice question there, but oh my God, it's going too quickly. And Sabuda, would you like to ask me one of the questions?
Yes, sir. It was who all satisfied to with the potential observers. That is, who can collapse the wave function successfully.
Did you say who can collapse the wave function successfully?
Yes, sir.
Yeah. And did you say humans? I don't know if you did, but at this moment in time, only human knowledge can collapse the wave function. But we don't even have to measure it, like the delayed choice proved. If we know which way it's coming without measuring, but a human could work out which way it was coming, then that collapses the wave function. Now, nothing else does. Does that answer the question?
Yes, sir, I guess. Has the double slit experiment been conducted with an observer as 5-year-old or a dog?
Yeah, but it doesn't matter who said that. Yes to both answers, questions. Yes, it has, and in both cases, it didn't collapse the wave function. And Einstein said, oh, I told you. But then he had to accept that somebody who knew what they were looking for could collapse the wave function.
So, Nader, can you please tell what does measurement really mean physically?
Great question. Whoever asked that, great question. And the answer is no, I can't. Remember I said measurement and observation is the wrong word, or are the wrong words. They're the only words we have. but they're classical Newtonian words. They're words we use in our world. But in the quantum world, measurement and observation are the wrong words to collapse a wave function. Measurement is only the nearest word we can get to. I might add, we can mathematically represent it, and we do so with, with Born's rule and the Schrodinger equation will plot the whole wave function. So we understand it very well, but yet we don't know. You tell me, why does it not collapse when the 5-year-old's looking at it? And if you remember what I was talking about with von Neumann, he's saying it won't collapse when any human is looking at it, or any measuring machine, or any dog, cat, anything. It will collapse when an extra physical object, not a quantum object, because that just entangles, the two quantum objects entangle. But at the end of the chain, the von Neumann chain it's called, there must be an extra physical. Now, you can call that what you want. It can be consciousness, it can be metaphysics, it can be mysticism. It's something that is wrapped up in the human, but not under our control. And the question is consciousness a function of the brain, or is consciousness external that we tap into? And I know a lot of the mystical people there will be thinking it's something we tap into. And I don't know, and no one knows.
Okay, sir, we have one question from your earlier slides.
Yeah.
We have measured or know that D0 produced interference pattern and the other interference particles.
Sorry, Subhuda, you're cracking up a bit. Can everybody make sure that they don't mute themselves? Can you say that question again? There's a lot of interference, but say it again, Subhuda.
We have already measured or know that D0 produced an interference pattern. The other rectangle particles reaches at a later time. So how can the interference pattern get changed to a clump?
How can the interference pattern what?
I will just copy paste the question again. You can see it in the chat.
That's a great idea, and I do apologize for my. There's interference. It's a good question because I very quickly saw that question and I liked it. Sorry, Madhu. I didn't mean to ignore your question.
Oh, I ignored it. I guess I have to look at it.
Yeah, I'll play Subhuda for everything.
That's the question again. I'm missing it.
Oh, you can't find it. Okay. Look, I can't. I think I know what the question probably was anyway. Look, we don't know how D0 knows that it's got to be a clump or a interference pattern. Oh, wait a minute. Sorry, it was up there for a second, but anyway, I don't know who asked that question, but if this doesn't answer it, ask the question again. We don't know. How does D0 know what the pattern, what's going to happen to its entangled brother? But it does. And it does it every time. It will be a clump or an interference. Technically, it should be an interference, agreed. But if its entangled photon goes to some detector, I can't remember the number, D3, I think, where we know where it's come from, somehow D0 will be a clump. I hope that answers the question. Are you there, Subhuda?
I'm there. I thought, sir, So is consciousness an inherent trait or is acquirable?
Yeah. I'm not the one to answer that question. In fact, your eminent meditators over there would answer that question a lot better than me. Aristotle said 2,000 years ago that the one thing we'll never understand is consciousness. And so far, he's pretty right. I'm a scientist, and I am not a mystic, and I'm not religious, although I respect everybody who has different beliefs. I tend to like to be something to be proven. Somebody said data without experimental backup is just an opinion. And to be honest, that's true. It's just a pretty story unless you can back it up with science. That's my take up on it all. So can you acquire consciousness? Yeah, I'm honestly not the one to answer that. But you're all entitled to your own opinion, that's for sure. Thanks, Michael, you're probably right. Oh, who said that? Somebody, I can't see your name. Someone has said no offense, but that seems pseudoscience. I'm with you. It's okay. I'm not taking any offense whatsoever. It does sound like pseudoscience. But what I'm telling you, whatever your name was, is that this happens. Again, the one thing I'd like to convey is that this happens. So now you can start interpreting it and saying what's really happening. So it's not pseudoscience. The delayed choice quantum eraser experiment is not pseudoscience. It happens, it's repeatable, it's happened hundreds of thousands of times, it's never ever failed. So the fact that an event that's already happened can be altered, that may not be the correct interpretation, but that looks as though that's what's happening. Now you're calling it, and by the way, I'm not offended at all, and it's good of you to say it. I'm glad you did, because it got me to rant on about this. It's not pseudoscience to say something crazy, because the delayed choice quantum eraser experiment is crazy. So it's got a crazy answer. And listen, everybody, we're in the quantum realm here, and crazy things happen. So I'm not going to say I don't believe your interpretation because it's crazy. It's like the many worlds interpretation. And that is that the wave function collapses for you with your interaction with the wave function. But for someone else, it hasn't collapsed, and therefore there are many different realities. And then you just think of the astronomical number that it could be. Now, when Hugh Everett first said this in the mid-60s, he was laughed at, he was scorned, but I'm telling you now, Sean Carroll, the leading physicist possibly in the world, Leonard Susskind, believe it for what I believe, and someone else who's, I can't remember, and I don't want to say, but someone else who's really clever now believes in the many worlds interpretation. And I can talk later on the different interpretations. The Copenhagen interpretation is what we've discussed, the many worlds theory interpretation, cubism, the Bohm pilot wave. There's many interpretations of what's going on, but it's not pseudoscience to start saying that the answer is consciousness. Thank you for that statement. So back to you, Sabota.
Hello?
Oh, yes, I'm here, sorry.
Sorry, sir. So one more question has came up.
Yeah.
How would you define consciousness, or like Is so basically is knowing something, in this case the results, it's consciousness. How would you define it?
Again, honestly, that's not a question for me to answer. That's a metaphysical question. I don't know what consciousness is. And I'm not even saying consciousness is collapsing the wave function. Dean Radin is. And I tell you this, he's got a point. But there again, Walesic and Stillfried are saying, yeah, you've got a point, but it's not science yet. But that doesn't mean he's wrong. Sorry, Sabuda.
What's the difference between seeing and measuring, or are they the same?
No. And again, I will say again, you've got observer. The observer effect is what it's all called. You've got observer and measurement, and they're not the right words. It's not what's happening.
Okay.
In fact, there was someone, I think it was Heisenberg, who said, when we examine quantum physics, we're looking at it from a human perspective. And that's true. We're using words observing and measuring because that's what we think. And to us, that is what's happening. We're trying to look at it. We're trying to measure it. But he's saying you can't do it from a human perspective. Quantum physics is weirder and strange, which makes it so appealing. And again, I stress, we can now use quantum computers to actually make computations that are mind-boggling, simulating the matrix, simulating every atom in the observable universe. We'll be able to do things like that because of these forces. And they're very reliable. If we'd have used them, far more reliable than our Newtonian forces. We used gravity and et cetera, to land a spacecraft on the moon. And I think it was only about 100 yards out or something, which obviously was fine. A quantum computer would get it there to between a millionth of an inch. So it's far more reliable, far more accurate, far more reproducible. The equations stack up. Even Born's rule. How can we know, looking at a wave function, how can we say, yeah, the coefficient, the absolute value of the coefficient, if you square it, that's the probability. It's great stuff. Okay, Suda. Subodhi?
Sorry, sir, I have posted a question in the chat. It is a bigger question, so you might want to look at it.
Yes, if you want me to, I will.
That with the recent advancement of studies being made in quantum mechanics and gravitational wave astronomy, that way.
I don't know where you are, mate.
One second, sir.
Oh, I got it. With the recent advancements and studies being made in quantum and gravital wave, I'm big into gravital wave, which is LIGO, and LIGO, which is the Laser Interferometry Gravitational Observatory. I don't know who wrote this question, but in there's going to be replaced.
Archit Srivastav.
Okay, Srivastav. Just so you know, Subhahanstra, I can't say your name. LIGO is about to be replaced by, I think it's called LISA, which is going to be in outer space. So it's going to be billions and millions of miles one way, millions and millions of miles the other way. And if there's more than one universe, the multiverse, the only way we're ever going to know is through gravitational waves that Einstein predicted. So I've gone, such a great question, Samantha. With the recent advancements in studies made in quantum mechanics and gravitational wave astronomy, how likely is it that we reach a unified theory joining the two vast fields of study, quantum mechanics and that, gentlemen, is the question of the day. Fantastic question, Subby. I'll call you Subby if you don't mind. Yes. It's long been known.
One more question, sir.
I'm sorry?
Okay, are you answering? I'm sorry.
Yes, I am answering that question. Yes, sorry,
Please continue.
Sabodi. I'm answering Sub's question at the moment, which is a great question. And it's always been known that the theory of everything, the one thing that doesn't stack up is gravity. We don't, quantum gravity, and there's a proposed postulated particle called the graviton, which is as hard to find as the Higgs boson was. Quantum gravity, everybody saw it in the scientific world, everybody believes that once we understand that, and gravity seems to have no effect in the quantum realm. But if we can get a theory of quantum gravity, we believe it will unite all of the disciplines, the very, very large and the very, very small. Let's keep in touch on that fact. Subodha?
Hello, sir. So, can you tell us how did this send that entangled qubit to satellite? As I thought, superposition doesn't last that long.
Yes, when it yes, that's because it's interacting with the environment. Is that what you mean? The entanglement doesn't last long. What do you mean by that? The entanglement will last until one part is observed, the observer effect. So when one part is measured, then what's happening is you measure one part on Earth, and then the one in the spaceship Nicias immediately collapses too. So they both collapse. And depending on the phase, they'll both be the same or opposite, but they'll both collapse instantaneously. But that's collapsing. That's not the same as decoherence or noise. Noise is just the, noise actually doesn't affect the result, I might add. It just makes it harder for us at this moment in time to find out what's going on. So you could have a very, very noisy qubit, and at the end of the day, it will reach the right theoretical quantum answer. I don't know whether I explained that well, but yeah. So next question.
Another great question, sir. We have the consciousness is mentioned to be the reality which is beyond matter. We also say that there are quantum effects inside brain which create consciousness. So is cosmic consciousness more related to quantum phenomena?
Don't know. Don't know. If you guys thought you were going to come here and I was going to answer every question, by the way, when I say I don't know, what I mean is nobody knows. And I don't mean that in a bad way either. I just mean scientists say, we don't know. We don't. I get, most of you guys will know who Roger Penrose is. Roger Penrose worked with Stephen Hawking. Oh God! And then the other guy's called Stuart. Someone, I can't remember his name now. Maybe somebody could put it in the chat. Begins with an A. Anyway, Roger Penrose. So I mean, this is one of the most intelligent guys ever lived. He believes consciousness resides in a structure we have in the brain, in our DNA. It's in our mitochondria. And, well, it's not in the mitochondria, so it's separate to the mitochondria, but it's what's called a microtubule. You might want to look that up. microtubule, the microtubule. Now, it's been long known in biology, which is what Stuart, begins with an H, now that I think. Stuart Hammersmith or something. He's a great quantum physicist, but he's more a biologist. And he says, we have this thing in everybody's brain called the microtubule. And it doesn't seem to do anything, but the older we get, it seems that proteins run along it, rather like, Oh, there's some other, I can't remember. There's some other bridge that proteins go from one part of your mitochondria to the other. Or the cell, I can't quite remember. I've studied this. Stuart Hameroff, Hammeroff, something very close to that. Anyway, Roger Penrose and Stuart Hameroff really believe that consciousness exists in the brain, in the microtubule. Now, if that is true, then it is quantum effects happening in the brain causing consciousness. But we really don't know. And to be honest, I'll give you my opinion. I'm surprised, and other scientists have said this, that Roger Penrose is so adamant that it's in the microtubule, because I don't go for it, but who am I? And yes, it could be, but whoever said that, good question. I've got one here from Shrishti, and we should, Subodha, I'm sure you'd like to thank a few people. Certainly we should thank Shrishti Singh, who really helped organize this. In fact, it was Shrishti, if I remember rightly, who invited me into the group, so I'm indebted to her. My question is, if nature is stopping us from knowing, good point, shouldn't we stop understanding it, as the results can be catastrophic if we finally understand it? I'm not going to disagree with you, Shrishti, because one, because you're a violent woman, and two, because we don't know. You're sort of saying, well, my own answer to that is no. We should always, always learn what's really, really happening. I don't believe there's something that we're not supposed to know, but I'm not disagreeing with you. You could well be right. In which case, it is dangerous to know what's going on. And it is amazing that nature's stopping us. And ostensibly, nature is deliberately stopping us. Back to you, Subodha.
I was saving the thanking for the vote of thanks session.
Yeah, I'm so sorry.
I too am very grateful for Shrishti for giving me this opportunity.
Yeah, and I don't know his name, Sai Pen. Is it Bravish or something? Anyway, you'll do all the thanking.
Yes, sir, I will do that. No problems. Is there any questions left? Please raise your hands or do something. I don't think so. Nobody's replying.
Excellent. Well, look, it's been a long, long session, and I'll pass it over to you, Subodhi.
So I have some, okay, no issues. Okay, thank you so much, sir. It was a wonderful session. And I would, from whole Indian community and everyone present in the chat, in the live sessions, I would sincerely like to provide my thanks to you. And similarly, thank you to Shrishti and Saipen as well. I don't know who Saipen is, but I'm thanking to him as well. Also, I think, look, Glitch, it was Bravish Ghosh. He invited me here. That him too.
Yes.
It was a wonderful session having you here. Thank you so much.
My pleasure. Thank you very much. And I'd certainly like to talk to you all in the future and work together. Thank you.
Yes, sir, we will approach you in case we need anything.
Please do.
Yes, sir.
Okay, I'll end it now.
Yes, sir, why not? Sure.
Thank you.